Hello, everyone. Welcome to Theatre 3 and Microsoft Graph Best Practices. Hi, I'm Dan Kershaw. I'm a program manager on Microsoft Graph. And today I'll be going through a few of the best practices you can employ when building an application that calls Microsoft Graph. So, you start out with a job to be done, thinking about building some kind of application. And you know that this app needs to call the Microsoft Cloud or Microsoft 365 services. And you've heard about this Microsoft Graph thing, and it sounds like it's the right API for the job. But how do you find out how to use that API and how to discover the various different features and capabilities that that API has? And then once you've started using it and you've got it integrated into your app, what are the kinds of, based on the kind of request you're making, what are the kinds of responses you need to be prepared to handle in your app to give your users the best kind of experience possible? And then if you're an ISV building that app, how do you think about the data that is your customer's data? Are you handling that data correctly? And finally, how do I optimize my app to make it run as fast as possible when going against Microsoft Graph? So let's have a look at a few scenarios and some tips and tricks here. First of all, what is Microsoft Graph? If you were at the keynote this morning, Yina did a great job of explaining it, but basically it's the gateway to your data in Microsoft Cloud. So you can get access to data and to insights that are yours or your customers all through one single REST API endpoint. So now you know a little bit, but not really enough. How do you get to know the API? So here are kind of first best practice recommendation. Go to our landing page at graph.microsoft.com, simple to remember, and find out a little bit more, and use our tool called Graph Explorer that allows you to explore Microsoft Graph. So I'm going to show you a little bit of that. So I'm going to go to our landing page, graph.microsoft.com. And here you see our Microsoft Graph landing page. And you can see various different options along the top. There are quick starts, documentation, samples, and SDKs, and various information. I'm going to go and click on Graph Explorer. Graph Explorer is a tool that allows me to make HTTP requests to the REST API, to Microsoft Graph, and see what the responses are. So, for example, I can click this query to get me, and you'll see it gets a response. That doesn't work. It gets a response that has Megan's information in it. So at the moment, I'm signed in with a sample account using a sample tenant. And on the left-hand side, you'll see a whole series of different saved queries that you can try out in different categories. And we have a load more samples that are available that you can try out. So this gives you a fantastic way to explore the API, try out various requests, and try these out and see what the responses are before you actually incorporate them into your app. And we hear from developers, this is one of the things that they do in terms of tips and tricks to understand the API before they integrate into their app. So that's Graph Explorer. So next, it's very important, based on the request that you make, now that you've got your app up and running, to know about the kinds of responses you can expect. Because if you don't take care of those responses, then you'll have a tough time making sure your application behaves reliably and predictably for your end users. So I'm going to show you a few of these different types of responses that you need to be prepared for. So the first one is pagination. So generally, servers will return a page size. They'll have a page size limit. So if you're asking for a collection of objects, if the collection size is larger than the page size limit that the server employs, then you can expect that you'll get your results returned in many pages. So you should always expect this odata.nextLink property in the response. So what this generally looks like is here we see an example when I make a request to messages, I get a next link back. That next link is basically, if you take that portion in green and put that in a GET request, that will get you the next page of results. So you keep following that next link until you get to the final page. And you know it's the final page because it won't contain a next link. So and the last tip here is make sure that you treat that next link as an opaque URL. You just take that URL, stuff it into the next GET request, and that will get you the next page of results. The next thing I want to show you are a series of errors that you may get back from Microsoft Graph. And there are many other errors that you could get back from Microsoft Graph, but I just want to highlight these 4 particular errors. So the first one, a 403, is sometimes a little confusing because, hey, my app already got some consent, so why would I get this error back? Well, in this case, in general, if you're using a delegated permission, this is to access the resource, you're going to need the, what gets looked at is both the permission that was granted to the application and the permissions that the end user has, the signed in user has when accessing the resource. And if the user doesn't have access, then you will get this 403. And generally, make sure that when you return an error back to the user, you don't disclose too much information. 404 is when an object's not found, and this can happen either if the resource isn't yet provisioned or if a resource that you're expecting to be there has actually been deleted. So if you don't handle this, you could return a weird error to an end user. And you should, as an extra tip, watch for restore. Some of our objects in Microsoft Graph can be deleted and then restored at a later stage. So and it's a full fidelity restore, so it will come back with the same data and the same ID. So you should be prepared for those kinds of things. The last 2 errors that we have, 429 and 503, are retryable errors. So when you see these errors, your app should retry calling Microsoft Graph. But in these cases, you should honor the retry after response and employ a back-off strategy. Also, when you make these requests, retry requests, make them over a new HTTP connection. So I'm actually going to show you a little bit of code that demonstrates some of this in terms of retry logic for transient errors. You can actually see this because we've updated one of our samples, the Graph webhook samples, to have a new helper module that does this transient logic. So I'm just going to switch over to show you that, but you can definitely peruse this at your own leisure as well. So let me switch to the other app here. And so here I'm looking at the Graph HTTP client.cs. And in here, I've got the main function, which is send async, which is basically the function that sends, or the method that sends an HTTP request to Microsoft Graph. And in here, the first thing you'll actually notice before we even get to the handling of the 429 and 503 is that we are logging the start time before the request and after the request is made, as well as a request ID. This is super important because anytime you have a problem calling Microsoft Graph and you need to get in touch with Microsoft support or you're filing a question on Stack Overflow, if you provide the request ID and the timestamp, we have a better way on our side to go and trace that error through our logs and figure out maybe what went wrong. So always log that information and respond with it when you have questions to Microsoft. After that, you'll see we actually handle the 429 and 503. So in here, what we're doing is we're looking at the specified time period that we obtained, i.e. in the retry header, and retry after header, and we are figuring out whether to use that or a secondary pause duration based on a back-off strategy, an exponential back-off strategy. And so we're choosing the one that's largest before we pause and make another request. And before we actually make another request in this while loop, if we hit this issue, we're actually going ahead and calling build graph HTTP client, which is basically creating a new client and hence a new HTTP connection. So that's the loop. Obviously, if we don't hit the loop, we fall straight out of it and we return the response. So this is showing you how we employed using some of those recommendations in one of our samples, which you can definitely look at after this talk. So as an ISV developer, you also want to be careful about what you do with customer data. So we generally recommend that you should call applications in real time, get a response, show that to the end user. But you may have some scenarios where you actually do need to cache or store data locally. In that case, we strongly recommend that your terms of service and your privacy policy make all of that super clear to your end customers about what you're doing with their data, how you're managing their data. Finally, I'm going to go through a series of optimizations that hopefully can really make your application fly. Oh, come on. So the first tip here is using projection. So in this case, what you're doing is, imagine you've got a table. Here you're basically selecting the columns of the table. So choose the properties that apply to your app, and don't send unnecessary data over the wire. You're going to see that's a bit of a recurring theme. So in order to do that, in Microsoft Graph, you use a $select query parameter. And here you can see it in action for the user entity, selecting given name and email. The next one we have is using filters. So last time we looked at the columns. Here we're getting the records or the rows in the table that really are all my application needs and no more. So again, don't send unnecessary data. And here we're going to use $filter. And we're using it in combination with $select. So here we're getting not only the columns we want, but only the users that are in the sales department. So in general here, we're saving on computational load where we have to serialize and deserialize less data, both in your client and actually up in our service, which means that the service will run much more efficiently. And so will your app. So again, on this same theme, for some of the write operations like post, patch, and put, if your code doesn't actually need to see a response, you can actually indicate to the service that you, through an HTTP request header, that you prefer minimal return format back from the service. This is generally a pretty good thing to do, but not in all cases. So you need to be careful when you use this. In a post case where you're creating a new object and the server is creating a unique identifier or generating the unique identifier for this new object, you may not want to employ this because your app may need to know the new identifier that was created with this new object. So use at your own discretion. The next set of optimizations talk about tracking changes. So imagine a scenario where you want to know about whether any users were deleted from your organization or from this particular organization if you're an ISV. You could be pretty naive about this, and you could basically just poll Microsoft Graph and store a cache of all the users and then look at a difference between them. But that's terribly inefficient, lots of computational expense. So our recommendation here is that you use webhook notifications whenever something of interest has changed. Also, it makes sense to put those notifications that you receive into a queue for later processing, and you can decide how to actually process those items. And you can find out more about webhooks at this aka.ms site. If instead you do actually need to cache data locally in your app, and keep that data up to date, then what our recommendation here is that you use Delta query. So Delta gives you a way to get just the changes that happened since the last time you called. And here, it means that if you were polling, then you'd be getting the same data over and over again. Through Delta, this allows you to stop basically retrieving the same data you already have. And it minimizes the network traffic and also reduces the chance that you may be throttled. Finally, and you can get more information on that at aka.ms graph delta. Finally, actually, webhooks and Delta Query work really well together. So one of the challenges with just using Delta Query is trying to figure out, well, what's the right polling interval that I should use? If I poll too frequently, then I stand a pretty good chance of my Delta returning me nothing. So I'm continually polling and processing nothing, which can be expensive. Alternatively, I could poll too infrequently, and now, although I'm getting data, my data isn't really up to date. So this is where webhooks and Delta together work better by using notifications as a trigger to make your Delta query. And what you can also do is have a backstop. So in case you don't ever actually get a notification in a particular period of time, you can force a Delta synchronization as well. And again, here, we actually have a theater presentation tomorrow at 1 o'clock, which I recommend strongly that you go to. And Barracuda will tell you all about the journey they've gone through in integrating with Microsoft Graph, and especially with change tracking. And finally, we have batching. So in this scenario, here you may want to make multiple requests. Say I have a modern application that has a user profile and an avatar that I want to show. And in this case, I need to make 2 calls to Microsoft Graph. Well, using JSON batching, I can limit this to just 1 request. And there are many other applications for batching here that can give you a lot of performance gains and conserve connection resources and lower bandwidth consumption, for example. And here you can find out more information about graph batching at aka.ms/gb. So I've gone through just a few of the various best practices that are possible with Microsoft Graph. But we actually have a document available, aka.ms/graph best practices, where we detail a whole series of further best practices. And it's up on GitHub, so it's open source. So if there are best practices either that you're expecting to see there, please go ahead and make a suggestion. Or alternatively, if you have some best practices that you've discovered when you've been using Microsoft Graph, again, please make some pull requests, and we'll gladly receive those. We love to hear from the community. And just to reiterate, we're continuing to invest in Microsoft Graph. Lots of new features will become available that were in preview. We're adding new data and to make Microsoft Graph more attractive, more capabilities to make it easier to use. And again, as a community, we love to hear from you. Please vote on user voice with any new features that you'd like to see. Here are some of the related sessions. We have one later today on cognitive services and Microsoft Graph, and the one on that Barracuda is doing on powering AI for real-time cyber fraud defense. And really, just get started today at graph.microsoft.com. Thank you very much for your participation here, and I look forward to seeing your evaluation. If you want to come and talk to me and ask me any questions, we also have some of our engineers from the Microsoft Graph team available. I'll be heading back to the Microsoft Graph booth, and please come find me and ask me any questions that you have about Microsoft Graph or about optimizing or best practices with Microsoft Graph. Thank you very much.